Hello and welcome everyone. Our today's question is form a palindrome. So we have given a string and we are to find the minimum number of characters to be inserted to convert it into a palindrome. So we have this string and to convert into palindrome we can insert this three characters on the starting to make a palindrome. So this question form a palindrome. We don't require to add on the starting. We can insert on any given position. So and we have this question also minimum character to add for palindrome. So in this question it is specifically said add at the front. So this question is significantly different from the original one. So feel free to go through this code if you want to learn new thing. So for now I'm just closing this and we will focus on this question. So we have this question and as you have guessed by looking at the space complexity n square, so we will surely apply dynamic programming. So let's build the approach. We have this question, we have this test case. So I'm starting with the different test case. So we have this. So as you know, palindrome means starting string starting and string ending must be equals. So we have L here and R here. As you can see, both character is different. So either we can add A or we can add C. We can uh, add A or C. So we have to find the minimum from the remaining string. So we have remaining A, B, C, D. Suppose we have added C at the starting. So R here, suppose we have added C. So now we don't require C at all. So just increment, decrement your R. So we will visualize that we have added our C at the starting or at the L index. So for now, we will decrement our R pointer. Same goes for starting A, B, C, D, C, and we will visualize that we have added A here. So L here and R here. We will visualize that we have added our Lth character at the Rth index. So why do you need to add if we can just increment our L and R stays same? So we will find the minimum length from this string and we will add +1. Why +1? Because we have to add either Lth character or either Rth character. So by this we will find our minimum uh, minimum requirement to make palindrome. So we have remain with this string and this string. So we have divided our bigger problem into sub problems. So let's build the DP. So why do we need DP? If you can visually interact with this. So we have L and R, and if L and R is equal, then just increment your L pointer and decrement your R pointer. So in this case, it is not equal. Let's suppose we have this case. So we are at this level. So in this case, both characters is not equal. So either we have this or we have this. So L here and R here. Whatever is the answer, the minimum answer, we will add +1 afterwards. So we will find minimum from these two and we will add +1. So suppose we are at this level L and R. In this case L and R is equal. So L and R is equal. So we are remain with L and R. So here this is the base case. So if your L exceeds your R or if there is a single character. So L and R pointing to same index. So this is a single character or L exceeds your R. So for that we will return 0. Means 0 addition we have to require to make palindrome because it is either a empty string or a single character string. So we will return 0. So let's code this. So first we have n, then we have a function. We have L and R pointer and string. So L and R. So if your I or L exceeds your R, so for that we will return 0. Else if the character is equal, then just increment your I pointer and decrement your L pointer. Uh, Increment your L and decrement your R. If this is not equal, then we have to find the minimum from the remaining subproblems. So the subproblem we have I plus 1 till j and I to j minus 1. So this is the remaining, and as you can see we have subproblems here, so that are overlapping. So in this case it is not equal, so we have BCD and we have ABC. So for this, as you can see, BCD and BCD, so we have two overlapping subproblems. So why do you require to solve again if we can implement our DP? So DP is helpful in this case. So we will implement integer DP. Why I am writing integer? So this is a wrapper class. Its initial value is null, so we can use this. So we will pass our DP, and if DP value is not null, means there is some value and we have been in this state before, so directly return. Else we will uh, or we have to store the state, we have to store the current state. So we are storing the state. Let's submit this code. Then we will optimize this code by applying tabulation. So that's it. Let's apply the tabulation. We have this string a, b, c, d and c. So as you can see, our answer we are getting from dp of 0 and n minus 1. So we have to return our dp from 0 and n minus 1. At the end we are returning from this index. So what is this index? So we have this 0, 1, 2, 0, 1, 2, 3 and 4, 3 and 4. So 0, 1, 2, 3 and 4. So we are getting from this index. So then you have to detect the base case. So what is the base case here? Base case here means either we have one character or we have empty string. So if the character is 1, so means I and j pointing to same index. So if this is a character, this is a character, this is a character, this is a character, or this is a character, means we have only single character. So for this we have answer 0. So suppose we have initially filled our DP with 0. So here I am taking integer DP. So initially it is 0. So I and j pointing to same index. So here we have 0. I and j pointing to same index means our string length is having one character. Our n is equal to 1. So for this, so this is called gap strategy. First we have filled this. So this, so here you can see I and j, here I and j 0 0, I and j 0 1 1, I and j 2 2, 3 3 and 4 4. Here I 0 1, 0 2, 1 2, 2 3, 3 4. So if you subtract j from I, so here we will get 1, here we will get 0, here we will get 2, here we will get 3 and here we will get 4. Why 4? Because I and j, so 4 minus 0 is equal to 4. So every diagonal is same. So we will traverse in this manner. So we have I have talked about the gap strategy before in my before one of my video. So you can watch that out. If I find that video link, I will surely put in the I button. So we have this index. So first we will fill this value, then we will fill this value, then we fill this value, then we will fill this value. So we will iterate in this manner. So analyze what we are doing in the memoization. If the character is equal, then jump to I plus 1 and j minus 1. So if suppose I at here and j at I at let's take one another string. So I at here and j at here, I and j. So if this character is equal, so we have checked for these characters. So we will increment our I plus 1 and j minus 1. So we will um, find our answer in this value. So suppose I and ij here. So if and I and j is here. So if this character is same, so we have to jump to I plus 1 and j minus 1. So we will check this index as we are checking in the memoization approach. So we will go to I plus 1 and j minus 1. If the character is not equal, then we are going to I plus 1 and j and I and j minus 1. So if the character is equal, this is for same, then we have to go I plus 1 and j minus 1, and we will if the character is same. If the character is not same, then we have to go I plus 1 and j or minimum we have to find from, and our second value is I and j minus 1, and whatever the answer be, we have to add plus 1. So using this manner we will get our answer. So now the question is how to iterate in this manner. As you can see, our I stays same, our I is 0. So we have a loop here. We don't have to iterate in this, in the 0th gap. So this is called gap. We will iterate from one gap and we will iterate till nth gap. So here, as you can see, I stays same, I starting from 0 and j value starts from, this is the 1th gap. So jth value start from 1, this is the 2th gap. J value starts from 2, as you can see 2 and 3 and 4. So j value starts from gap, and j value is closest to n, so we can write j less than n. We can also write I less than n, but j value first reach the n, so we can just write this only. Then we have to increment our I and j. So first we have this index, then we go to this index, because we are incrementing our I and j both at the same time. So that's why, so by iterating, by moving I plus 1 and by moving j plus 1, so we will reach this index. By moving I and j, so we will reach this index. At the end we have our answer at this index. So let's code this. So n, then dp array, then gap. Here same as I've told you. Then if the character is equal, so here I am applying ternary operator. If the character is equal, then just go to I plus 1 and j minus 1. If the character is not equal, then we have to find the minimum from I plus 1 and j, and I and j minus 1. So we have to add plus 1 afterwards. At the end we have to return our answer. So answer is present in I0 and Rn minus 1, because using this we are fully iterating our string. So if you are watching till now, a click on the subscribe button is highly appreciated. And if we have successfully solved this question, you can find both the solution in the description box. If you still have any doubt, feel free to ask in the comment section. And thank you all for watching this video.